Hi, in this video I want to show you my Dover math book collection. Now it is a little bit misleading because this is not my entire collection. This is just some of my Dover math books, but I made a video recently and I made a comment about how I should make a video about all my Dover books, and a few people were like, make the Dover video, make the Dover video. So I thought, okay, let me just grab some Dover books and let me show you some books. So these are kind of in order. I have my favorite ones at the bottom of the pile, and we're going to start at the top. So I'm just going to go in order, and the ones I've spent the most time with are down here at the bottom, and so we'll get to those last. Those are a little bit more interesting, I think, probably because I've spent more time with them than the other ones. Nevertheless, these are all great books. By the way, for those of you that don't know, Dover is a publishing company, and they take old books, math, science, and other subjects too, and they reprint them and they sell them for affordable prices. And you can find all of these on Amazon, brand new usually, at a really good price. I'm going to leave links in the description to this video to all of these. Some Dover books, even the reprints are hard to find. So in those cases, if I can find other copies, maybe even an original copy, I will leave a link in the description. So let's start with this one here. This one's called Introduction to Analysis by Maxwell Rosenlicht, or Licht. Let's look at the contents. Most of these Dover books, again, are very affordable. A lot of them don't have answers because they're reprints to older books, so they might be a little bit terse. For example, look at the copy right here, 1968. It says, this Dover edition, first published in 1986, is an unabridged and unaltered republication of the work first published by Scott Forsman and Company, Glenview, Illinois, in 1968. So these are reprints of old, hard-to-find books. And believe me, the originals are hard to find. I've looked as a collector of math books. Even some of the Dover books are hard to find. So let's look at the contents here so you see what you get. Starts with sets, which is absolutely fundamental if you're trying to learn analysis, and then the real number system, and then metric spaces. That's a good place to start, and then continuous functions, and then some differentiation. There's problems at the end of each chapter, Riemann integration, interchange of limit operations, the method of successive approximations, and then you have some partial differentiation and multiple integrals. That's a lot of topics, right? I mean, look how thick this book is. So that tells you something about this book. It is very terse, it is very concise, but it's very affordable. People always wonder, should I buy the book? Is it worth it? Let me just make a simple analogy before I go to the next book here. If you're hungry and you want pizza, you can order a pizza, or you can buy a math book. You can't eat your math books, but when you eat the pizza, it's gone. The math books you'll have for the rest of your life. So that's why I like math books. They are quite affordable. Some math books are expensive, but none of these should be expensive because they're Dover books. That's why I think people wanted to see this video, because these are actually very affordable math books. Let's go to the next one. This is one that I think is interesting because it's an actual book on numerical analysis. It's called A First Course in Numerical Analysis, and it's by Ralston and Rabinowitz. I don't have that many books on numerical analysis. I never took a course in college on numerical analysis. There was a numerical calculus course available when I was an undergrad, but I never took it. Wow, Israel, cool. Wow. Look at the topics here. Introduction and preliminaries. What is numerical analysis? Sources of error. I do have some interesting numerical analysis books, though. Maybe I should make a video just on numerical analysis to show you some of the older books. And this one's an older book. Let's look at the copyright on this. I'm sure it's much, much older. The Dover one was published in 2001, and it's a reprint of the 1965. Wow. 1965 by McGraw-Hill, so a long time ago. Approximations and algorithms, interpolation. There's some more topics here. People often ask, do I read these books? Do I go through all of these and read them? No, absolutely not. Typically what I do is I'll pick a book at random and I'll sit down for half an hour sometimes and maybe do some problems, maybe make a video. So yeah, it's just kind of like a fun hobby thing. And it keeps your mind fresh. I recently made a video on, age limit for studying math, and there was a lot of people there who were older who wanted to do math, and there is no age limit. Hints and answers to problems, let's look at that, 557. So there's quite a few you can see. Look at the typesetting, really old school typesetting. Really old school. This next book is very good. It's near the top, but I've spent more time with this book than the other books. This one I've done a couple exercises. I think I read 1 or 2 entire chapters. It's been a while though. Elementary Real and Complex Analysis by George Shilov. This is a famous book, and it's just a book on analysis. It's got good proofs. Let me show you the topics briefly. I like this book. Translated and edited by Richard A. Silverman. Revised English edition. 1973, Massachusetts Institute of Technology. Wow. So, like other analysis books, it starts with real numbers, sets, metric spaces. So very similar to the other books. Very similar treatment. Limits, continuous functions. You might be wondering, why would you need more than one book on analysis? The derivative, higher derivative, the integral. And I think it's because math is hard, and a lot of times you'll read stuff in math books and it just doesn't make sense, or you're just not interested. Different authors present things different ways, and that helps to have more than one resource. And you never know. Like I said, you can just pick up a random math book, sit down here, like on a desk like this one, and then just start doing mathematics. Selected hints and answers, that's useful. That's very useful, even if it has some. Some answers is better than none. Yeah, it's pretty good, right? Quite a few. So nice book on analysis, and again, super affordable compared to other, textbooks out there. This is one that I've had for a very long time. In fact, this is one of the first Dover books I bought. It's called Elements of Abstract Algebra by Alan Clark. And there's a story here. The guy who told me to get this book, I don't want to repeat his name because he's from the internet. He's a friend I had on the internet who used to hang out in an IRC math chat room. And he was a huge troll, and he was a mathematics god. And he was so good at math. People would come into the chat room and ask questions, and he could just prove it. Like, you could just give him a statement, and he would just like spit out a proof. The story was that he was like some rich, old, evil, retired New Yorker who had some types of degrees in mathematics, but he was really evil and really mean to people. And he recommended this book, so I bought it. And it's a great book, but it doesn't have answers. So it's just like, let me show you the format. See how it's numbered? 38. So you have to show that. So it's just exercises. It's like exercises, definitions. They do give you some proofs, but it's not great for beginners. Looking at this now, I'm thinking, oh yeah, this is pretty good. So my opinion of this book now is very different from when I got the book. This book is incredibly hard to learn from on your own. You do need to have some background before you buy this book. But again, looking at it now, I think it's fabulous. Yeah. When I got this book, I wasn't very good at writing proofs. So if you're not good at writing proofs, I don't recommend this book. If you have some proof background, it's super affordable, and it's a very clean, organized exposition of abstract algebra. Yeah, and the guy who recommended this, the story with him was he had a reputation on the Math Channel for being good at math, and he was really mean. So that kind of left an impact with everyone else. And one day he disappeared, and the rumor was that he died, and no one knows whatever happened to him. So that's a weird story. Here's one that I haven't spent much time with. This one's called First Order Mathematical Logic by Angelo Margaris. Let's take a look at the contents. Let's look at the previous owner. Preface to the Dover edition. Let's see when this was from. 1967 by Angelo Margaris. Go Angelo. Many errors have been corrected for this edition. A few minor corrections that I could not squeeze into the text appear in an addendum, which also lists some books published since the first edition. And he's thanking some people here for their work. Yeah, writing a book is a tremendous feat. It is an incredible amount of work. This is a book for junior, senior, and beginning graduate students, okay, wow, of mathematics who have little or no acquaintance with abstract mathematics. The entire book can be covered in one semester. Okay, so it tells you a little bit about the book. Talks about set theory, axiomatic theories, connectives, the predicate calculus. So this is a book on logic. It's pretty good. I do think that, you know, if you're going to choose between this and another book for, you know, learning logic, I do think, I mean, this is a great book. It's not a bad book. I do like the Vellman book though, but this is also good for beginners. And again, it's affordable, so you can get both. But yeah, the Vellman book is a great book, I think, for learning to write proofs. And it's around the same price range and size as this one, but still a good book. Here's one on number theory. Number theory is a subject that I've only learned through self-study. So I never took a class on number theory in college because it always conflicted. I mean, one semester it came down to number theory versus topology, and it's like, okay, I need topology for my degree, so I'm going to take topology. This is a pretty good book on number theory. It's affordable. I like it. I also think the book by Long is good, but that's not a Dover book. This is, and this is going to be more affordable than the Long book. So nice choice for number theory if number theory is something you want to pursue. So it's going to take some effort though. It takes a little bit of effort to learn number theory on your own. It's not exactly the easiest thing to learn. This one's a bit strange. This is like the only book in the entire world that's written in the way that this one's written. It's a book on vectors, and Banesh Hoffman, he takes a very interesting, inquisitive approach. You know, he makes you think about vectors. This is a nice book to sit down with a cup of tea and say, hey, I want a different approach. I just want to learn some mathematics. My mind is open, as Paul Erdos used to say. So, interesting book. Yeah, some awkward questions. Yeah, when are two vectors equal? So he really makes you question everything you know and tries to really think about everything. It's kind of a nice take on things. Gets you to think about things from a different perspective. He does have some analogies in there. I remember there was an analogy that I didn't understand at first when I read it, and then I had to go back and read it again, and then I understood the analogy, which is one thing I don't like about analogies. A lot of times people will make analogies in an effort to make things easier, but they make things harder. So still, here's another interesting one. It's called The Divine Proportion, a Study in Mathematical Beauty. Okay, and this is also a Dover book. This one, it's a soft cover, but like it feels pretty tough. The Divine Proportion is a very interesting thing. If you don't know about it, I recommend this book or just going on Wikipedia or watching a random YouTube video on it. The Texture of Beauty. I prefer Wikipedia. I prefer reading to videos. Even though I make videos, I do prefer reading, and I prefer books over the internet. The internet is great, but I just prefer books. The Texture of Beauty, the Divine Proportion, Analysis of Beauty, Phi and Fibonacci, Art and the Golden Rectangle. Interesting, right? Beauty and Mathematics. Yeah, there's some interesting things with the divine proportion and the Fibonacci numbers, and it's a little bit mysterious. You know, you come back to that question: is mathematics discovered or is it invented? Mathematics is a human invention. It's just strange how things show up in nature so much. Certain things that we've created, perhaps, we find in nature. Yeah, so interesting. Now it's getting really good. So I'm gonna rearrange the stack here. I like these. Now I'm getting to my favorite books. So this is where it gets interesting. So if you're still watching, awesome. If you're not, then you can't hear what I'm saying. So this book is a must-have, okay? So worth having. If you're a math major, buy this book. It's called Counterexamples and Analysis, and it's just got some interesting examples. You never know when you're going to need an example of something, and it's just a fun book to have, and it's so affordable. It's just got really interesting examples. Let's look. Here's an example. So it tells you the examples in the contents. A nowhere continuous function whose absolute value is everywhere continuous. A function continuous at one point only, right? So it has different things. A function that is everywhere finite and everywhere locally unbounded. So just counterexamples, right? Examples of very specific things. Here's some infinite series stuff. A divergent series whose general term approaches 0. So wouldn't that be like the sum of, as n runs from 1 to infinity, of 1 over n? That should work. Let's check, because that one should work. Let's check, see what they give us, because that's the harmonic series. It's page 54. Ah, that's the one they give us. A divergent series whose general term approaches 0, the harmonic series. So boom, there it is. So stuff like that. And you saw how I read that, and I was able to do that. I was able to know what it was. That's because I've studied math, right? And I think that's the thing that people don't get. You know, I can look at that in the contents and say, oh, I know the example. How do I know that though? Just years of experience, and it's not because I'm smart, right? It's not because I'm just a regular person. It's just through practice and time, you learn mathematics. But great book. I'm getting goosebumps. I love this book. I just got to smell it. And again, it's not a book that you can sit down and really work through. I mean, you can, but it's just a nice book to have in your collection. And its friend, its sibling, Counterexamples in Topology, is equally good. This also has very, very good examples of, you know, things that defy intuition, right? The closed infinite broom, the integer broom, nested angles, the infinite cage, Cantor's leaky tent, Sierpinski's metric space. I actually have a book written by Sierpinski. I should, it's really hardcore, it's really old, and it's falling apart. I should make a video on that and talk about it. It's very, very advanced. Yeah, so that's a very good one. Here's one for beginners, finally. Essential Calculus with Applications. This is one of the first Dover books I ever bought, and it's a great book. It's not gonna have as many exercises as like those big, thick, modern calculus books that people use in college today, like the one by Stewart or Larson or Thomas, or, you know, those really big, thick calculus books. It's much thinner. It takes a different approach. I remember picking up this book when I first got it, and it was talking about inequalities. And I was like, ooh, inequalities. It's talking about intervals and stuff. This is cool. So it's just a little bit different. The layout is a little bit different than the modern books. Super affordable calculus textbook. So it's not a workbook. So you should think about that too, like, because there's really good workbooks you can get brand new. Like Chris McMullen has a bunch of those on Amazon, and I reviewed them, and they're great for learning. But they're not textbooks. This is a textbook. It's got actual, like, it's more content, right? So great calculus book if you're on a budget, or if you just want a different, more old school take on the subject. This is a good one. Here's one that was written by a very famous mathematician, Balakrishnan. Very concise book. It's a tough book. I'm not going to lie. I'm not going to, as I say, sugarcoat it. This is going to take some effort. I do think this is easier to read than like the Rosen book or the Grimaldi book, but it's still pretty tough. I don't think it's the best book for beginners. I think the book by Epp is perhaps a better choice, but it costs way, way more money than this one. So this has tons of exercises, as you can see. And I'm pretty sure it has answers, because I've worked, yeah, it's got some of the answers, selected exercises, but it doesn't have all of them. And it's got some cool stuff in here. Let me see if I can find, I was reading some stuff from here the other day. I went to, I had a minor accident, not an accident, I didn't hurt myself. I went surfing a while ago, and I broke someone's windshield on accident. And so I had to go get the windshield replaced, and I had to wait at the windshield place. And so I brought this book with me, and I'm sitting there at this windshield place, and there's always guys walking past me, these mechanics, and I'm sitting here reading this discrete mathematics book. And there was a proof in here. I can't find it. I believe the proof was by Paul Erdos. Yeah, I'm pretty sure it was this book, but yeah. So great book. It does take some effort, but it's a nice choice for discrete math. This is probably the first Dover book I bought, or one of the first. I bought this when I was barely learning calculus. And I remember taking this with me to the dentist, you know. That's the nice thing about these books, right? You can take them with you places, you know, if you're going to the park, if you're going for a long car ride, you can grab a Dover book and you can take it with you and you can read and you can learn. And I remember reading this book and thinking, ooh, I'm so smart. I'm reading a book on complex variables. Now he starts by talking about like the quadratic equation, I believe. Yes, he starts about talking about, probably the first time a school child comes across the need for any kind of number other than the real numbers is in an algebra course where he studies the quadratic equation. I was like, I get it. I understand this. So very fun book. It's got a lot of mathematics. It's on complex variables. And here is one that's very thin, and it's got a very psychedelic cover. This is written by Emil Artin. He is the father of Michael Artin, who also has a book on abstract algebra. This is called Galois theory, and it's based off his notes. It's really concise. You do need to know some mathematics. You need to know some algebra, but he covers it all. I mean, look, it's not that many pages, right? So kind of a fun choice if you want to try to learn Galois theory. Chances are, like if you don't know any abstract algebra, you won't be able to buy this and say, hey, I know Galois theory. It doesn't work that way, but it's still a good book to have and you can learn from it. Keep in mind some of the definitions are a little bit different when you're reading books like this because it's an older book. Let me see if I can give you an example. Here's the contents. So I think even on the first page there should be an example of how there's a little bit of, here you go. A field is a set of elements in which each pair of operations called multiplication and addition is defined analogous to the operations of multiplication and addition in the real number system, right? Yeah, okay. There's something here where it's a little bit, if multiplication in the field is commutative, then the field is called a commutative field, right? So in today's books, all fields are commutative, right? So little stuff like that might get to you. It used to get to me. It no longer does. I accept it. As a collector of math books, I know that the definitions vary. The notation varies greatly, and it's just something that comes with the territory. It comes with mathematics. And then here we have one of my favorites. This one, last I checked, I don't know if it's available on Amazon. I'll try to find it. But for a while it wasn't. It was out of stock. It's a great book on topology. It's probably the easiest topology book you can get other than Topology Without Tears, which is free. You can Google it. It's a free topology book. This one's great, except it starts with neighborhood systems, which is a little bit non-standard, but then it shows that its definition of a topology via neighborhood systems is equivalent to the regular definition. But it's a very gentle introduction to the subject. It has very well-written proofs. I've read this entire book, and I think it's excellent. I highly recommend this to anyone wanting to learn topology. This one is a rare case. This is a topology book. It takes a very standard approach, unlike this one. This is a much more advanced book. It has proofs, but they're written at the level that they are written in a topology book. So if you've read topology books, you know what I mean. It's a little bit hard. But this one has full solutions to all of the exercises in the back of the book. And I'm talking full proofs, right? So now some of the proofs are a little bit terse, but still, awesome book. Must buy, one of my favorite books. So that's it. These are some of my Dover math books. Dover math book collection is probably what I will title this video because that's what this is. But I do have more Dover books. I have a lot more Dover books. I have a lot of books that I've never talked about. And so hopefully I will make more videos and show you some more of my books. Some of them are really interesting and some of them are easy to get. Some of them are hard to get. So hopefully you've enjoyed this video. Until next time, good luck and keep doing mathematics.